In these problems, we are asked to graph the equation and indicate the slope if it exists. Well, we know immediately in this particular case that the slope exists because we are told that the equation is in slope-intercept form, or we're given the equation in slope-intercept form. And we know that the slope is the coefficient of the x. So the slope in this case is -3/5. Please note that the slope is just the coefficient of x. It doesn't actually include that variable. So the slope in this case is -3/5. We can use that to graph the equation. And the way that we would do that is to first look at the 4, which is the y-intercept. So I can locate 4, positive 4, on the y-axis, which is right here. And then from there, I can use the slope to get me to another point on that particular line. Since the slope is -3/5 and the slope is a ratio of rise to run, from this point I can go down 3 units for my -3, and then to the right, +5. That will put me at another point on the line. So again, I'll go down 3 over 5 to put me at this point. I need 2 points to graph a straight line. There's my 2 points. If I connect them a little better than that. Let's erase that. Okay, now let's try. Connect those points. Now it's still not a great line, but that would be a rough sketch of the line y equals -3/5 x plus 4. For this one, we have 4x plus 2y equals 0. One technique for graphing linear equations would be to put the equation into slope-intercept form and then graph it. So to put the equation into slope-intercept form, I have to get the y term by itself. That means subtracting the 4x from both sides. So the 4x's cancel over here. That leaves me with 2y equals -4x. You can put the plus 0 if you want, but you don't have to. And then I would divide both sides by 2. So I'm left with y equals -2x. Again, if you want to put the plus 0, you can. This equation is in slope-intercept form. The slope is the coefficient of the x, so that means that the slope of this line is -2. Another way to think about that is -2 over 1. We can use that when we graph. We know that the y-intercept of this particular graph is 0. So I'll find 0 on the y-axis, which is just the origin, and from there my slope is -2, which is the same as -2 over +1. So from my y-intercept I'll go down 2 and over 1, which puts me at this point here. I need 2 points to be able to graph a straight line, so I'll connect these two to get the graph of that line. For this one, we could also put it into slope-intercept form. To get the y by itself, I could first add the x over 4 to both sides. So that leaves me with y over 8 equals x over 4 plus 1. Now what I could do is clear the fraction. Since the y is not by itself because of the divided by 8, I could multiply each term by 8. So multiplying each term by 8 keeps the fractions, or clears the fractions rather, and it also keeps the equation equal. So what happens is my 8's cancel over here, and I have y equals x over 4 times 8 would be 8x over 4. That simplifies to 2x, plus 1 times 8 is 8. So this is my equation in slope-intercept form. Again, the slope is the coefficient of x, so the slope in this case is a +2. The y-intercept is 8, so I'll find 8 on the y-axis. And since my slope is 2, from that y-axis, or from that y-intercept rather, I'll go up 2 and over 1, which puts me here. Connect my points. And there's my line. Finally, in this particular equation, I have y equals 3.5. I don't have an x term. Since I don't have an x term, that tells me that the only conditions that have to be met on these particular points is that the y term has to be 3.5, or the y coordinate has to be 3.5. So some points that meet those conditions might be 0, 3.5, 1, 3.5, negative 10, 3.5. I could go on and on. I really only need 2. So if I plot 0, 3.5, there's my negative 10, 3.5. I'll throw him in there. 1, 3.5. These are all points that are going to lie along a horizontal line. So the line y equals 3.5, or y equals anything really, is a horizontal line. The slope of a horizontal line is always 0. So the slope of this line is 0. Vertical lines have no slope, but horizontal lines have a slope of 0. Another way to think about that is if you take the original equation, I could rewrite it in slope-intercept form as y equals 0x plus 3.5. That would give me my slope of 0. It would also tell me that my y-intercept is 3.5, and you can see that this line passes through the y-axis at 3.5.